Okay, so welcome back. And now that we've talked about parametrizing a curve, or not parametrizing the curve, eliminating the parameter for a curve, okay? Now there are many situations where we would like to write parametric equations for a given curve, okay? So and there are actually many ways of doing this, as you'll see. Okay, so being able to eliminate the parameter and then writing one as a single equation in terms of x and y is one thing, but to go and split it up into two parametric equations, there's usually always more than one way to do that, right? And so I'm going to show you a couple ways that we could do that. Because again, if you're given an xy function, and you're not given any parametric equations with that, you could really split it up into two parametric equations in many different ways, okay? So this is where there isn't really a right answer. There's an easier way, there may be an easier way and a harder way of doing it, but that's again something separate. So I'm going to do an example, and I'm going to show you two different ways that you could define two parametric equations, okay, that would describe this curve. So in this case, we're going to start with y equals 2x squared minus 3. So this is one of the ones that we did before, okay, but this is what we're starting with now, and we're pretending we have no idea what the parametric equations were, right? Let's say we're just given this, and that's it. And I want to be able to split this up and write this using two parametric equations, okay? So, first thing is, now again, this is a parabola, right, that opens upward, okay? Now, there's an easy way of doing this, right? We could always, make the substitution this, right? So this is always easy. We can always, and this is like the easiest way to do this, okay? If you were asked, like for example, on a test or a quiz, to write two parametric equations that describe this equation here, or to what we call parameterization of a curve, right? If I want you to do that, so parameterizing this. So if I asked you, okay, here I give you this and I want you to parameterize this equation, which means just to write it in terms of two parametric equations. I could just basically do this, right? I could say, well, let x, oops, let, come on, Mark. Okay. Let x of t equal t. I can do that. There's absolutely nothing wrong with doing that. Okay, and if that's what I'm going to use, then guess what? Then I can go ahead and say, okay, y of t is then equal to that. And I'm done, right? And there's nothing wrong with doing that. Okay? So the parameterization really is dependent on what you choose for your substitution. Okay? Now, since there's no restriction on the domain of the original graph, there's no restriction on the values of t. Okay? So in this case here, t would be not restricted. Okay? And we have complete freedom in the choice for the second parameterization. Okay? Now, we could choose a different parameterization. Okay? So, for example, instead of this, let's change this. let's just choose another one. Okay, so let's x of t. So again, literally, we have complete freedom in choosing what we want. Again, don't make it too difficult on yourself. And some choices are going to be easier than other choices. So let's do this. Let's make this equal to 3t minus 2. Okay. So then what would y of t need to be? Well, what would we do? Well, we're going to substitute, right? We're going to take x of t, right, equal to 3t minus 2, substitute it here. It's another substitution that we're going to do, just like before. So all we're going to do is just take x and substitute x for this. So y of t is going to equal what? 2 times the quantity 3t minus 2 squared minus 3. And so now we just have to simplify. So this is going to give us 2 times 9t squared minus 12t plus 4 minus 3. Right? And then this is going to give us 18t squared minus 24t plus 8 minus 3. And so our final answer, we get 18t squared minus 24t plus 5. And so this becomes our other parametric equation. Oh, hold on a second. I dropped something. Oh. I don't know why I keep doing that. 2, not 3. Okay, there we go. And again, there's no restriction on t because there was no restriction on the domain. Okay, if there was a restriction on the domain, then we would have to do what we did before and use the restriction on the domain of x to tell us what the restriction on the domain of t is going to be. Okay, so don't forget that. You could be given something where there is a restriction on the domain. Okay, even if it's something where you have a restricted value, right? A restricted value on the domain, like if you have a rational expression or a square root or an even root, something like that. So you want to be aware of those types of restrictions that come up as well. But other than that, I will see you next time. Oh, wait a minute. Do I have one for you? Yes, I do. It says find 2 different sets of parametric equations. So here's one for you guys to work on. So find 2 different parametric equations for the graph of, to represent the graph of y equals x squared plus 2x. Again, do an easy one and then just choose another one, right? And just see if you can do it. And again, there's many different ways of doing this. Okay, you have complete freedom in choosing how you set this up. But again, don't make it too difficult on yourself, but practice. See if you want to come up with 3 or 4, you could do that too. Okay? See you next time.